A proportional flow divider is a device that divides flow into two or more flow parts. By dividing the flow, a single pump can be used to operate multiple circuits at the same time. The two types of proportional flow dividers are the spool and the gear or rotary. Spool-type proportional flow dividers divide the flow into two flow paths. The input flow is divided proportionally between the two output flow paths. Common flow divisions are 30-70, 40-60, and 50-50. Both output flow paths are pressure compensated, so the flow division will remain constant even with varying loads and pressure in two circuits. If the input flow varies, the output flows will vary proportionally. If one of the output flows is blocked, the divider will block the other output flow. The gear-type proportional divider can divide the flow into two or more flow paths. The positive displacement of the gear sections produces a constant division of the flow, even if the loads and pressures in the output circuits vary. The output flows are proportional to the input. As the input varies, the output flows will vary proportionally. If one of the output flows becomes blocked, all of the output flows will be blocked. Pressure intensifies in the circuit that is initially blocked. A relief valve placed in the circuits downstream of a proportional flow divider will prevent pressure intensification. The relief valve will also keep the flow divider from blocking flow to other circuits. Gear-type flow dividers can be used to combine return flow in circuits. Most spool flow dividers are not designed to allow reverse flow through them. There are spool-type combiners and combination divider-combiner units. This is a spool-type proportional flow divider. These flow dividers consist of a housing, a spool, and two end caps. The housing has 3 ports, 1 inlet port, and 2 outlet ports. A narrow passage connects the center cavity and each of the outlet ports. Inside the housing is a sliding spool with cross-drilled holes in the center and through the entire length of the spool. The spool is available to move freely in the housing. Flow from the inlet enters the center of the spool through the cross-drilled hole. The flow divides and flows to both ends of the spool. Fluid flows out both ends of the spool, around the ends of the spool, and out the narrow passages to the outlet ports. If pressure at outlet 2 increases, the spool will shift to the left. The spool moves slightly in response to differences in pressure between the two outlets, resulting in pressure compensation for both outlet ports. This is accompanied by the opening to outlet 1 being partially closed, while the opening to outlet 2 is opened slightly more. The flow to both outlets remains constant. If pressure at outlet 1 increases, the spool will shift slightly to the right, opening the passage to port 1 and slightly closing the opening to outlet port 2. The major components of this gear flow divider are the end covers, gear sections, section dividers, and tie rods. Flow enters one end cover and flows through a passage to each of the gear sections. Fluid pushes against the gear teeth, causing them to rotate in opposite directions. The fluid between the gear teeth and the housing is carried around to the opposite side of the gear section. As the teeth mesh, the fluid is pushed out of each outlet port. The gear sections are connected by a common shaft, which causes all of the sections to rotate at the same speed. The inlet flow is divided proportionally between each section. A bypass flow control used as a flow divider is called a priority flow divider. The outlet ports will typically be labeled CF for controlled flow and EF for excess flow. A priority flow divider is often integral to the port cover of the hydraulic pump. When flow to a circuit is critical, a priority flow divider is used to help assure that the needed flow is available. Common applications are systems with steering or braking circuits. The priority or controlled flow port is pressure compensated, but the excess flow port is not. All input flow first goes to meet the required flow of the controlled flow circuit. Flow will remain constant through the controlled flow port as long as it is at least equal to or more than the controlled flow setting. Any extra flow will exit the excess flow port and can be used in another circuit. If the excess port is blocked, the flow will remain constant through the controlled flow port. If the controlled flow port is blocked, all flow will go through the excess flow port. This is a pressure-compensated bypass flow control. Bypass flow controls are often used for priority flow dividing applications. The primary components of this pressure-compensated flow control are the housing, the main spool with a metering orifice, the spool biasing spring, and a relief valve. The metering orifice controls the amount of flow to the priority circuit. The biasing spring holds the spool to the left, blocking the flow path to the excess flow port. Fluid entering the inlet is metered through the orifice where it flows to the controlled flow port. Excess flow trying to pass through the orifice causes the pressure drop to increase. The upstream pressure pushes the spool to the right, compressing the spring and opening the passage, allowing the remainder of the flow to exit the excess flow port. The spring and the spool work together to maintain a constant pressure drop, resulting in a constant flow across the orifice, and diverting excess flow to the excess flow port. If pressure in the priority circuit reaches the relief valve setting, the relief valve opens and diverts the priority flow to the reservoir. This bypass flow control. Bypass flow controls are often used for priority flow dividing applications. The primary components of this pressure-compensated flow control are the housing, the main spool with a metering orifice, the spool biasing spring, and a relief valve. The metering orifice controls the amount of flow to the priority circuit. The biasing spring holds the spool to the left, blocking the flow path to the excess flow port. Fluid entering the inlet is metered through the orifice where it flows to the controlled flow port. Excess flow trying to pass through the orifice causes the pressure drop to increase. The upstream pressure pushes the spool to the right, compressing the spring and opening the passage, allowing the remainder of the flow to exit the excess flow port. The spring and the spool work together to maintain a constant pressure drop, resulting in a constant flow across the orifice, and diverting excess flow to the excess flow port. If pressure in the priority circuit reaches the relief valve setting, the relief valve opens and diverts the priority flow to the reservoir. Power steering units are used to assist in the steering of many types of mobile equipment. The power steering unit is a fixed displacement rotary metering valve which is activated when the steering wheel is turned. Most power steering units are gerotor or geroller design. Please refer to the motor section of this training for a better understanding of these designs. Without rotation of the steering wheel, the centering spring holds position of the spool and sleeve, and the fluid flow is allowed to pass through the pressure port to the spool and sleeve and to the tank port of the steering unit. Rotation of the steering wheel counterclockwise rotates the spool and the sleeve against the force of the centering spring, allowing fluid to pass through the rotating spool-sleeve valve. Flow is metered through the gerotor section of the steering unit, equal to the displacement of the gerotor and the rotational speed of the steering wheel. The fluid flow is ported to the open side of the gerotor and metered to the closed side as the gerotor rotates, and flow passes out through the L port of the steering unit. The relief valve is passed through the P port to the T port of the unit and flows to the reservoir. Fluid flow is routed to the steering cylinder and turns the wheels. Fluid flow is routed to the steering cylinder and turns the wheels to the left. Rotation of the steering wheel clockwise reverses the flow path through the unit. through the unit and turns the wheels in the opposite direction. Pump flow not used in the steering circuit passes through the opposite direction. Pump flow not used in the steering circuit passes through the tank port of the unit to the reservoir and to other downstream functions through the functions through the power beyond port of the unit if provisions are made for this option.